Alright, in this video, I am going to show you how to solve this equation. It is 0 is equal to the determinant of this matrix right here. So I'm assuming that you know how to do 2 by 2 determinants. It's that product minus that product. So we need to bump it up to 3. So there's like one little piece that you need to know about a 3 by 3 determinant. And I usually talk about it as a checkerboard. Plus, minus, plus, minus, plus, minus, and plus, minus, plus. We would follow that pattern if it was a 4 by 4, 5 by 5, etc. If you know this pattern and you know how to do a 2 by 2 determinant, then you can do a 3 by 3 determinant. So I'm just going to show you how to do a 3 by 3 determinant. If I have det of, I'm just going to do 1, 2, 3, 4, 5, 6, 7, 8, 9, close. All right, so a determinant has all kinds of properties, and this video is not really to show you why those properties are true for this or why this is related to what a 2 by 2 determinant is. It's just how do we take a 3 by 3 determinant. What it is a combination of 3 separate determinants. So I'm going to go, well, actually what I'm going to do is I'm going to start with the 1, 2, 3. I'm going to write 1 times, I'm going to leave a gap. All right, det. And then I'm going to go minus. Why am I taking minus? Well, I took the 1 here, it got a plus. And the next thing I'm going to take is a 2, and it's going to get a minus. So I'm going to go minus 2, and then times another det, and I'll show you what that det will be of. And then the last number I take is 3. And I'll show you what goes in there as well. So the reason why I have this checkerboard that goes, has more than just the top row is because I could do this determinant. I'm basically using the top row. I did a 1, a 2, and a 3. I could use a 4, a 5, and a 6, and I would follow this checkerboard pattern. If I were to use a 7, an 8, and a 9, I would follow this. For our purposes, we're just taking the 1, 2, 3. So in here, in each of these 3 spots, I'm going to put a new 3 by 3 determinant. So this one came from that right there. So what I'm going to do is highlight that. Well, I guess I'll go like that and that. Notice if I highlight the row and the column that 1 is in, it leaves me with a square matrix left over that is not highlighted. Those 4 numbers right there, the 5, the 6, the 8, and the 9, are going to go in right here. So let's write 5, 6, 8, 9. And now we're going to skip this one for now, and then we're going to do the 3. If I were to cross off that row or highlight that row and that column, notice I've got 4, 5, 7, 8. That goes here. So I will write 4, 5, 7, 8. And now the last one I'm going to do is when I take the 2, that's this 2 right here. This 2 right here. I will highlight its row and the column that goes with it. And notice I get a 4, 6, 7, 9. So those are the numbers that are going to go here. So I will go ahead and do that. 4, 6, 7, 9. And now, when I'm doing these determinants, I get 1 times, I go this product minus that product. And I've already done that. That comes out to be negative 3 minus 2 times, this product minus that product. I get, what do I wind up getting? Negative 6. And then I get plus 3 times, that's this 3 right here, this product minus that product, because that's what the det is. And that one gives me negative 3. So when I simplify this out, I get negative 3 plus 12 minus 9, which in this case comes to be 0. That actually has some significance, but I'm not really worried about that for this context. it has some significance for this matrix right here. It is sort of just a coincidence because I took these, I just wanted these numbers so that you would be able to see where all the numbers were going through here. So let's have you try one. I would like you to try the det of 1, 2, 1, 3, 1, 1, 1, 1, 0. I would like you to hit pause, and then I will do it and show you the answer at the end and walk through the work. So go ahead, try it using the model that you just learned. Okay, here we go. I got 3. Hopefully you did too. Some common spots. One, people forget this negative all the time from the checkerboard. So if you got -1, that's probably what happened. Secondly, all right, let's do some of this. This gets highlighted out for the 1, which is that one, and then I'm left with those right here. Then with the 2, this and this gets highlighted out and leaves me with 3, 1, 1, 0, 3, 1, 1, 0, along with the -2, the negative from the checkerboard. And then for the last one, these get highlighted out, 3, 1, 1, 1, 3, 1, 1, 1, right? And then from here, it's just some dets, and you got to be careful with your negatives and stuff like that. So I got those for the dets added, and I got 3. So hopefully you feel okay with doing a 3 by 3 determinant, and that's going to allow us to solve the equation that we had up above. Okay, so I have this determinant. I'm going to do my checkerboard. I'm going to go across the top row. So I get -2 minus lambda times a det. What's in that det? Well, it's going to be this square right here. So I get -2 minus lambda, 1, 1, -2 minus lambda. Then I get minus, from the checkerboard, a 1 times a det. What is in that det? I got this one, this one, and that -2 minus lambda. 1, 1, 1, -2 minus lambda. And then I get plus, I get this one times this square here. So 1 -2 minus lambda, and then 1, 1. All these vertical bars are determinants. So with this one, I'm going to get -2 minus lambda times, all right, this determinant is the most funky one. I got this product minus that. So that's actually -2 minus lambda squared minus 1. And then I get -1. I'll just write negative. And then this determinant. So that determinant, -2 minus lambda, come back the other way, -1, close, and then plus, all right, this one gives me 1, that's this product, minus this product. When I get that negative here, it's convenient because it makes those two positive, and I get +2 plus lambda. All right, next I am going to multiply this in. I'm going to kind of distribute it in. This is the same as that, so it gives me -2 minus lambda cubed. And then I get, all right, this times that actually gives me +2 plus lambda because of the negatives. And then I get, all right, I get +2 plus lambda plus 1. That's this. Oops. And then I get plus, that's 3 plus lambda. All right, so this stuff all works out well. This is kind of the beast of this part. And to do it, I'm going to take advantage of a couple things. One, if I have a cubed, but throw a negative in there, that is the same as -a cubed. So I'm going to actually move this negative out and write negative, and then I'll have these two being positive. And when I do that, I'm actually going to write the lambda first because it's easier that way. So this is the same as that. If I combine all these pieces over here, what do I get? you can see there's actually lambda, 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 so that's plus 3 lambda, and then 2, 2, 1, and 3, they add to 8. And remember, this is all equal to 0, so I'm eventually going to try and factor it. So then the question becomes, how do I do this? And I hope you know how to use Pascal's triangle to expand polynomials. 1. So I take this row with the 3's in it, and I get negative. All right, the 1 goes with the lambda cubed, plus I get a 3 times I get the 2 to the first power and the lambda to the second, and then plus another 3 times 2 to the second power squared times lambda to the first, and then I get a 2 cubed. That's how I expand with Pascal's triangle, and I still have my plus 3 lambda plus 8. If I simplify all this out, I get negative lambda cubed. Actually, you know what I'm going to do? I'm just going to, well, I got time. Negative lambda cubed plus 6 lambda squared plus 12 lambda plus 8. All those are negative. Plus 3 lambda plus 8. So from here, look, all these are negative. So I definitely going to have a negative lambda cubed. And then I'm going to have 6 lambda squared. There's no lambda squared, so it's negative 6 lambda squared. I got a 12. It's negative. Add 3. That gives me minus 9 lambda. And then minus 8 plus 8, they cancel out. So this determinant, if I simplify it all the way down, gives me this. And remember, I have that thing equal to 0 up here. So to solve this, I am going to actually factor a negative lambda out. And that leaves me with lambda squared plus 6 lambda plus 9, which gives me negative lambda times lambda plus 3 squared. And remember, whoops, this was equal to 0. So I get lambda equals 0, and then I get lambda equal negative 3. Sometimes we write that as negative 3 comma lambda equal negative 3. I guess the easier way to write this would be lambda equals 0 comma negative 3 comma negative 3. I write it twice to indicate that it is repeated. So hopefully you're on board with how to solve this equation, and you feel maybe a little bit okay with doing 3x3 determinants. There are all kinds of tricks, but that is not what this video is about. So see ya.